Confidence intervals and Z-scores. So if we're talking about Z-scores here, we're back to talking about the standard normal distribution, Z, which follows a normal with mean 0, and standard deviation 1. So within 90% of the mean, we have from negative 1.6449 out as far as 1.6449. So this is symmetric. The corresponding value here and here is 1.95996, and for 99%, 2.5758. Now we can certainly find these on the calculator. So interactive, and go for an inverse distribution, inverse CDF, and these are all symmetric, so go for a center, and let's say we do this one, 0.95. So 0.95, and we've got the standard normal in here already, and we can see negative 1.95996. So that's this value here. So we can find it easily enough on the calculator, and we can also find it for other distributions, so we don't always have to use the standard normal values. We can now predict with a level of confidence the mean of an entire population if we know the mean and standard deviation of a sample of that population. From the central limit theorem, we know that the mean of the population will equal the mean of the sample, and we will assume the standard deviation of the population equals the standard deviation of the sample. Obviously, we really have to be taking a large enough value of n for this to be true, but we'll just assume it in most of the questions we do. So, mu is the population mean, sigma the population standard deviation, x bar is the sample mean, n is the size of the sample, and then one way of finding the confidence interval is to use x bar take away k times sigma over root n, x bar plus k sigma over root n, where k is the z-score value we looked at just now, depending on whether we're having a 90, 95 or 99% confidence interval.